All right, hello. We're working on Unit 6 still. I'm on day 2 of this. This is page 5. So up at the top there is some review. So find one positive, one coterminal. One positive, one negative coterminal angle with 700. So this again means you need to add and subtract 360 degrees. Okay, so some possible positive ones would be 1060 and 340. Again, there's lots of options for these. A negative one would be negative 20 or negative 380. Draw an angle that is approximately negative 105, x-axis, y-axis. We always start here on the x, so past 90 and draw it into the quadrant 3, so this is 105. Just like we did yesterday. Okay. There are several other measures to how we determine angles, and common ones are degrees, and the next one we are going to be doing is called radians. So it's a version of degrees, and it's going to be relating degrees to pi. So when you do radians, a lot of times, not 100%, but a lot of times there is actually pi in the radian measure. Now, you can have something like 3 radians. That means the pi was actually calculated or multiplied into it. But usually it's something like 2 pi over 3, 3 pi over 4, 1 pi. It's usually just something with pi in it. Okay. So a little bit of review for you before we get into what it is. Circumference is either pi d or 2 pi r. So circumference, so that's for a circle. That's the only one that has a circumference. Remember, that's its perimeter. Okay. So 1 radian is a measure of the central angle, so whatever the angle is, that intercepts an arc. So the arc is on the outside here, so we're going to use the S. That's the arc. So an arc that's equal in length to the radius. So the radius here and the arc are the same. So theta, the angle measure here, is the relationship of the arc here versus the radius. So anytime we're doing a radian measure of a central angle, it's the arc over r. So arc length over the radius. Alright, so to relate this from degrees to radians, a central angle of 1 full revolution corresponds to, well, first of all, remember, so all the way around, that's 360 degrees in a circle. So an arc length of S over R, which is 360 degrees, so going all the way around in a circle. So all the way around is the circumference. So we use 2 pi r. So the number of degrees around is 360. The circumference of that is 2 pi r. So the s I can actually replace with the circumference and divide that by r. So r's cancel out and we're left with 2 pi. Okay, so 1 revolution of a circle. Okay, so 1 complete revolution is equal to 2 pi radians. Now, we're going to be working a ton in what's called the unit circle. A unit circle is a circle with radius equal to 1 unit. So the unit, centimeters, meters, miles, it doesn't matter, but it's just going to be the value of 1. Okay, so kind of think about this over here real quick. In terms of degrees, we already talked about this is 0 degrees, 90 degrees, 180, and 270. And we end with 360. In terms of radians, this is 0 radians. All the way around in a full circle, this would be 2 pi radians. Halfway through the circle, so if a full circle is 2 pi, halfway to 180 is just 1 pi. 90 is pi over 2. And so each of these, anytime we do 90, it's pi over 2. So 1 pi over 2 to 90, 2 pi over 2 to 180, and then 3 pi over 2 to 270. Okay, so those are the basic ones we're going to start with. So when we do this, just a reminder, because I'm going to be asking you to do complementary angles, but I'm going to ask you to do it in terms of radians. So complementary angles are either 90 degrees or pi over 2 radians. Complement. Okay, so if the problem is given to you in degrees, use the degrees, but if it's given to you in radians, we're going to use radians. So find the complement of angle pi over 12. So normally we would, in degrees, you've always done it in geometry, 90 minus your angle. So in terms of radians, we take, instead of 90, we take pi over 2, and we subtract pi over 12. Now, this is all fine and good, and we can get common denominators. This would be 6 pi over 12, and this actually comes out to 5 pi over 12. Your calculators will help you do this. So you take in your calculator, 1 divided by 2 minus 1 divided by 12. And just leave the pi sitting there, because it's just going to be in your answer. Hit it, and you're going to get some decimal. Then you want to hit math 1, it'll give you the fraction. And it'll give you 5 over 12. Or you can also do alpha y equals, and that will be the fraction button you can do. So just add pi into your answer. Alright, supplementary and complementary angles. Supplements angles that add to 180 degrees, or in terms of radians, or 1 pi, or pi radians. Okay, so we either do 180 minus the angle, but in this case we have pi for the 180 minus whatever angle we're given, 5 pi over 6. Okay, so on your calculator, you should end up with 1/6. So you type in 1 minus 5 divided by 6. Hit enter, then hit math 1, enter, or math enter, enter, and you get 1/6, and just add in the pi. So 1 pi over 6, or just pi over 6. Alright, coterminal angles. So yesterday we were doing them where we add and subtract 360. So if we want them in degrees, we add and subtract 360 to have a positive one, or we subtract it until we get a negative one. So in this case, we're going to add or subtract a full circle in radians. 2 pi. So it's plus or minus 2 pi. Find one positive and one negative coterminal angles. 2 theta equals pi over 6 and 17 pi over 6. So we're doing pi over 6 plus 2 pi and pi over 6 minus 2 pi. Okay, and use your calculators and get those numbers and the fractions. Okay, so then do it for the other one. So that's for pi over 6, and then for 17 pi over 6 plus 2 pi 17 pi over 6 minus 2 pi. And again, if it doesn't work to give you the negative 1 or positive 1 right away, oh yeah, sorry. So I got 5 pi over 6 the first time, so then subtract 2 pi again. Alright, that's where we're going to stop for today. As far as the notes go, I would like you to come work on just page, oh no. So on page 7, up to number 5. Okay, so do everything up to there, but we're not going to convert yet because we haven't done those. Talk to you later. Bye.